is real, it's the next episode.
Well, welcome back to part 6 of the 18650 mount-in. In this episode, I want to take a break from recovery of these batteries and let's have a look at a mini project where we can repurpose some of these batteries. I also want to introduce a new gadget, a tool that I've bought that may come in useful in future episodes, but also let's have a look at this power bank I bought. It basically takes up 18650 batteries, and I think it'd be kind of fun to build this and share what I find with you guys. Okay, so let's build it. So the construction is quite simple. It consists of a solar cell at the top, which I assume is going to produce a low amount of current during sunlight hours. So at the front, it's a very simple operation. You have here a button. When you press it, it should tell you how charged the system is with these 4 LEDs. The LEDs will also indicate if the solar cell is receiving a charge, and they should come on one by one to show how much charged it is. You've also got another LED here, which is a torch, and you also have a mini USB charger here, which I think that will be used quite a bit. You've got 2 USB outputs. One is going to be higher end, high output 2 amp, and one is going to be lower end 1 amp standard. And that's all it takes. A very straightforward construction, nice solid little unit. And let's have a look inside. So the construction, as I said, is very straightforward. You've got a frame here that holds the solar cell. On the back you have terminals, plus and minus obviously. You also have the main body that holds the control board and the charging bit, and then you have the base itself. On first impressions, it is of a very poor quality, but what do you expect? The solar cell itself is misaligned. Looking at the circuit board here, I can see that even the SMD components are not so well soldered. In fact, one of the capacitors seems to have dislodged itself during manufacture and looks like it's mating with one of the resistors. But again, as I said, it was never an exercise in getting a quality component. It was just to see how this kit looks and have some fun with repurposing some of these batteries. First thing, whenever setting up batteries to use in something like this, the whole point of us checking the capacity of the batteries is that they can be very similar batteries of the same capacity rating. So I'm going to use the poorer ones. I'm going to just quickly go through and try to find the highest capacity ones that are as close to 1000 as possible, and then we'll just use them. It looks like we'll need 5. Yeah, we'll need 5 anyway to begin with. I'm also going to try to use the same style batteries, same chemistry. So once we've got those, then these have been sitting for about a couple of weeks. Let's just see if internal resistance has killed the batteries, or we've had some voltage drop. So last time I charged this battery, it said 4.2 volts using the TP4056. And if we measure it today, after a few weeks, it's measuring 4.05 or 4.06 volts. So it's dropped 0.06 of a volt, which is not bad. This one is showing 4.16, and it's still showing 4.16, so that's okay. Okay, so this one was measured at 411 a few weeks back. It's still 411, so that's the keeper. That's the keeper. 4.13, and that was 4.14. So this one actually has gained some energy. This one measured 4.11 and it's reduced down to 3.7. So that one needs to go. This one was 4.1 and it's reading 4.07, so it's dropped 0.02 of a volt. This one was 4.12 and it's dropped 0.06 of a volt. That's the ones that we're going to keep for this pack. Overall, they are in okay sort of condition. They're not losing voltage. Okay, let's go on to the next thing, which is spot welding these. Yes, I know what you're going to say, but I saw on eBay for £180 and I thought to myself, this is going to end one of two ways. This is either going to be a very useful tool or it's just going to blow up my face and be another Chinese joke. Whichever way you look at it is going to be educational. I thought I'd like to share that with you guys and girls. On first impressions, you actually do get quite a bit for your money. So £180, you get a 50-watt soldering iron, which is variable from 150 degrees to 500. You get handheld spot welder. You get a jig that can hold up to 6 18650 batteries. You get 50 nickel strips. You get some spare copper tips and some spare, I think they are some sort of yellow plastic caps that hold them in. And the machine itself is actually not too bad. It first of all has a variable current for the spot welding. It has adjustable pulse, so you can add up to 4 to 8 pulses, and that's about it. Now I could open up the machine to have a look inside, but to be quite frank with you, that scares the hell out of me. When you switch this baby on, it trips my fuse box, and I have to go back and reset the switch. And it has a very nervous sounding hum, but I think that's part of the transformer that's producing that high-end current to give you that spot weld. And the way it works is you put your batteries in there. I don't think there's any need to put it in any order, so I'll put it in this order. And then on the top you can squeeze in the nickel strip.
That's good.
Tuck the nickel strip into there, and then you've got these grooves, and then you can spot weld this in place. So the next step is that you can then, where the grooves are, you can spot weld it there. And spot welding is very easy once you've got your setting. So I'm going to set this to 4, which is the current of that, and then the pulse, just leave the pulses as it is. It's switched on, and I've got my foot pedal ready. What you do is you push up, you can hear it click, and you push the foot pedal and it's spot welded. It's worth doing it a few times just to make sure that it's very well spot welded. I strongly urge you to wear safety glasses, and as you can see it sparks quite a bit. So these tips have got a little bit corroded. Got to clean those contacts. Let's try it now. I shall now pass on to my son, who wants to have a go at this, and let's hope he doesn't electrocute himself.
Now we've done the positive side, we can move on to the negative side. We've inserted the nickel strip, and we can do the same process of spot welding like we did with the positive side. Okay, now we're ready for spot welding. First one. That was easy. That was like child's play. Let's take it out of the jig and see how well it's welded.
Yeah, it looks quite solid, doesn't it? Good job.
Thank you.
Alright, fantastic. So that was a very solid weld we got there. That pack is nicely welded, it's solid. The nickel strips are a bit thin, but then I think they came as part of this. Oh! It's gone loose there.
Soldered that back on.
I think that got over welded and just came loose. I soldered the back on. Okay, I managed to weld that in very quickly. And there's another one that's just... What the hell's going on? Another one's gone loose. Right. Well, actually, what we could do now is maybe give the hand welder a go and see how that performs with this machine. So on first impressions of the hand spot welder, it's actually quite good. You've got very thick copper wire here with gold connects on the end. The actual handheld bit is spring-loaded. But yeah, it's quite ergonomic and it's quite comfortable to hold and seems very well insulated. The connection is very straightforward. I don't know if there's any particular order. There's no markings on here, but you put one end in here, another one in there, and that's it. Job done. So here's the one that fell off. Let's put that there. Again, you need to set up the foot pedal with this one, and this is very scary for me. But you put it in, you push it down. It's spring-loaded as well, and fire. There we go. It wasn't very good, that one, but let's try again. Push down, and that's it. So I think that's not bad for using with a localized spot welding without having to maneuver around this, especially if you've got a big pack. I think the only criticism is the lead is quite short, and I think this needs to be positioned quite high up so that you can easily access the whole battery that you're working on. But you can imagine if you're doing a whole massive bank of maybe 92 batteries in parallel, it's going to be very cumbersome and probably hard on your wrist after some time. So on the circuit board you see there's two wires. There's a B plus, a Sun plus, a Sun minus and a B minus. So clearly the Sun has to do with the solar panels, and the B plus and the B minus is to do with the battery, and that's what you weld it to. I took the opportunity to solder on some silicon wire. This is, I believe, a 20 gauge wire, more than enough for these batteries, and we'll just connect up our soldering iron that came with this welder and see how that takes. So we connect our soldering up to this machine. That's what's so nice about this machine. It's got a built-in soldering iron station, so this is used for spot welding and soldering batteries. We'll switch it on. Let's set that to 300 degrees. Basically, as I explained in my previous videos, we get high heat, which is very localized and won't damage the batteries. That's actually a very good soldering iron. It heats up super fast, really fast compared to my 30 watt one. And we'll put a bit of solder on the nickel strip to begin with. Let's see how fast that goes on. I'm not using any flux on this one, and almost instantly touching it has melted the solder. Now we do the positive side. Look at that, almost, I just touch it and it's yeah, soldered it. Right, next thing to do is tin the wires. The way I do is I take some solder from there and I would just touch the wire and it should take it, no problem. Put it on the end of the soldering iron, touch the wire, and it should stick to the wire. Keep your nozzles clean. Right, so we've tinned the wires. We want to tin the solar cell as well, and that will be the last thing. Here we go. Right, let's now solder these wires up to these terminals here. There we go, that's the batteries done. Now we solder the solar panel, and it has a ground and a volt in there, so that should be straightforward as well. Right, that's it. We just assemble the whole thing. That sneaks into there. and get the cases. So before we put everything together, let's just test everything. If I press this button, oh, we've got half a charge, so this is charged 50%, that's what it's telling me. And if I flip this over, as you can see, it's charging it. I don't know at what rate it's charging it, but it's charging it nonetheless. You should check to see how much it's charging, at what rate. So I'm just going to see how much voltage that solar cell produces. Right now I've got it covered up, so it's not producing anything. If I uncover it, it's just hitting with our lights here. And I've got, oops, 2.3 volts, slightly in the shade. If I move it more into direct light, now it's reading 3.2 volts. So let's put it directly in the light and see what happens. This is all using indoor lights, normal artificial lighting conditions. So I got nearly 3 volts there. So there's definitely a charge going in. I wonder what current it's going in at, so let's see if we can measure the current. So just going to check to see how much current this solar cell produces. So I'll switch my multimeter into milliamps, move the red wire from the voltage to the milliamp, leave the black one on common. And what we need to do is now desolder one of the wires so we can basically tap on to the flow of current. There we go. So I'll introduce some crocodile clips. That one over there. Okay, so from the indoor lights, it's producing 0.48 milliamps, which is hardly anything. So it might be producing close to 4 volts, but the 4 volts is being driven at almost half a milliamp, which means that these batteries would take forever to charge. Let's see what it's like if I took it outdoors and see how much it would produce then. So we're outside, we got some sun at last, and now it measures in sunlight. I did see a 62 there. I did. I'm seeing 60, or what's happened there? 61. I can really feel the heat of that sun. 61. 61. So 61 milliamps. That's it. We peaked it out there. That was interesting, wasn't it? So inside we just barely got a reading, and outside we got 60 milliamps, which is not a great deal. So again, a prime example of a poor quality product from China. It looks good. It all looks good when they take the pictures on eBay, but in reality it's crap, basically. As crap as it can be. Anyway, we'll carry on with this exercise and we'll just solder, job done. Right, that's about it really. So the only thing to do is to put this all together, and amazingly they just expect you to just put this on top, but I think it needs to be glued in. So I'll get some super glue and glue that in. Clip it all together. There we go. It looks exactly as I pictured it on eBay, but with all the hidden gremlins inside that no one knows about. Got a nice black anodized surface back here. I reckon we should laser etch a logo on the back. Let's do that as well. Well, what you saw there was a laser etch of a channel I follow called Hypertard. He's new to vlogging, and he's a motorbike enthusiast like myself, and he basically rides and gives his views of the world. So go and check him out, give him some support, and let him know that I sent you. I'd also like to give a big mention to Adam Welch. He, like myself, is a big 18650 fan, and he's got some really informative technical videos that I think that you will find most interesting. Go check him out, subscribe to his channel, give him some thumbs up, and let him know that I sent you. So let's summarize what we learned on this video. The question we put forward is it worth investing in a spot welder? Well, yes and no. If you're looking to do an electric bike, or you're looking to carry a large power bank that is mobile to charge some heavy duty gear like cameras and video cameras and so on, well then yes, it's worth investing in a spot welder. You'll get a better quality connection, the batteries themselves will be more rigid, and the job itself will be more professional. If you're doing a power wall electric vehicle and you've got large scale batteries, 1000 plus, I don't think so. In my opinion, it's probably better to buy a high powered soldering iron. I'm getting a lot of comments on my channel between 50 to 80 watts, which I absolutely agree with. So invest in a good quality iron and do that job with soldering. Well, again, thank you very much for following me on this episode and subscribing to my channel. I've had some very kind comments and some great feedback from you guys, which I've taken all on board. I'm still trying to motivate myself to tackle that 18650 mountain. Watch this space. Hopefully we will be looking to do that at some point, and I do have some ideas about how I can speed that up, which I want to share with you. Thank you so much. Join me next time.